We've been talking about logs. Today we're going to look at some logs that you can actually do on the calculator. They're the two logs that show up most often. They are the common log, which we'll look at first, and the natural log. The first one that we're going to talk about is common log. You've seen this log button on your calculator before that says log. Log, short for logarithm. Anytime you see that, that is the common log. So anytime there's a log and there's no base number shown, it is base 10. Base 10 is the common log. So anytime it's just log, it's really understood to be log base 10. We can do common log on the calculator. Uh, so looking on your calculator, the common log button should be over kind of on the left hand side on TI 8384. It's kind of next to the 7 here. So you can hit log, enter 3, hit enter, and it'll tell you what the common log or log base 10 of 3 equals. It's equal to about 0.4771. You can try this next one too. If you do log of 0.2, we could do that one. Again, type in log, type in 0.2, and hit enter. And we see it is equal to about negative 0.6, not rounding, it'd be 0.6990. So you can solve, or you can find out log base 10 called the common log with your calculator. All right, let's think back a little bit now. We looked, or we've done some problems here where we've had 3 to some exponent equals another number, and we've always been able to solve those. They've been set up pretty nice for you. Like on this one, we know 3 to what power equals 27? 3 to the third power equals 27. So here we know x equals 3, and we've been able to solve it because it's been kind of nicely set up for us. Well, let's look at number 3 on your worksheet. This one says 3 to what power equals 11? 3 to what power equals 11? Well, we know some powers of 3, right? We know 3 to the first power is 3, so it's not 1. We know 3 squared equals 9. Well, it's not 2 because 3 squared equals 9. And we just did 3 to the third power equals 27. So there's no whole number power that equals 11. How do we solve for the variable then? Well, looking at what we have here, we know 3 squared equals 9, and 3 to the third power is 27. 11's in between there, so 3 to some power between 2 and 3 must be the answer. So the power, whatever the exponent is, must be bigger than 2 but less than 3. How do we know what that is? Here's where logs are going to help us out. We can solve this type of problem by using logarithms. And how it works is we're going to take the log of both sides. We're going to add log in on the left side. We're also going to add log in on the right side. So when you're solving with an exponential equation, both sides of an exponential equation can easily be written as powers in the same base, and you solve by taking the logarithm of each side. All right, here's what we can do now. We know from looking at our power rule yesterday with logs, anytime you have an exponent of a log, we're able to move that out front and write it as a product. So this would be the same as x times log of 3 equals log of 11. If we want to solve for x now, we can simply do it by getting rid of this log 3. It's being multiplied. If we divide both sides by log 3, we can get the answer. This cancels out. So x is going to be equal to log of 11 divided by log of 3. And here's where your calculator can be used to solve that. We can figure out log of 11 divided by log 3 with our calculator because it's common log now. So if we go on our calculator, we can type that in. So we want to hit log of 11, so type in 11. Make sure you close the parentheses. Some of your calculators might put the parentheses in for you. If they don't, make sure you close that up. Divided by, now we hit log 3, hit enter, and it should tell us the value. It's about 2.18, and that kind of falls in line with what we said. We said the exponent would be somewhere between 2 and 3 because 3 squared equals 9, and 3 to the third power equals 27, and 11 is between those. So the exponent here is about 2.18. So 3 to the 2.18 power is going to be very close to 11. All right, let's try another one here. On number 4, we kind of want to do the same thing here. We want to figure out what 6 to what power equals 42. So on this problem, again, the key is to put log on both sides. Log of 6 to the x equals log 42. Our exponent property now, anytime you got log with an exponent, we're able to move that out front. I want you to see it for tomorrow if you can finish this one off and figure out what that exponent is going to be about equal to. So see if you can solve through that one and find it. All right, so that's common log. The other log we're going to be looking at today is called the natural log. Natural logs are basically regular logs with base e. Now this value e, remember pi is equal to about 3.1415. It's a number that's an irrational number. It keeps going, but it has an actual value. E is also like that. E, or our exponential, has a value of about 2.7182. It's a number. So we can have it as a base here. So log base e of 4 equals x, that's called the natural log. And because it's useful in a lot of different occupations, use this for a lot of different stuff, it shows up very often, it has its own notation. Log base e of 4 can also be written as ln of 4. ln is the notation for natural log. And it means log base e. So anytime we're dealing with that, we use the natural log. For some of the problems here with natural logs, we can solve those out on your calculator. ln is usually next to your exponential button because they are related to each other. So we can do some of these. If you have one of these TI-30 calculators, you can see over at the right where it is. Find it on your calculator. If you have, a lot of you have 83s or 84s or the TI Inspire, it's also going to be over on the left-hand side. On this one, you can see it's kind of over by next to the 4 button. Your E button's also over there. So if you want to find E squared, on this one, it's right behind your ln button. You can hit second ln and it pops up E, type in the exponent, hit enter, and you can figure out about what E squared is, like 7.39 or about equal to that. You could do it to the negative. If you have a negative one, you can do it the same thing. Second ln, you can type in negative 1.3. We can find that value. It's about 0.27. ln, now we can do ln too. ln, or natural log, is that button that the exponential is behind. So we can type in ln. The natural log of 4 is going to be about 1.38. So these ln ones you are able to find. You can try this ln 0.05 if you want. So ln and e, they're related to each other. They're inverses of each other. That's why they put them next to each other on the calculator. Looking at the graphs of these ones, the natural exponential function base e. So if we have the function y equals e to the x, you can see the graph here. Notice a couple of things. It does go through the point 0, 1 like a lot of our other exponential graphs. And it also has a 0.1e. So it's one of those exponentials, starts growing slowly, increases exponentially. The inverse to that then, if you switch around all the x and y values, is this graph right here. And you can see the equation of that is y equals ln x. Again, notice if you look over, like we talked about a little bit a couple days ago, this graph keeps decreasing here, never touching the y-axis, so never actually gets to x equals 0. So if you try doing ln of 0, that one does not exist. 0 is not in the domain. Same with logs and negatives. If you try doing natural log of some negative number, does not exist. It's not in the domain. All right, so we're going to try doing a little bit of solving here. On problem 5, they want us to figure out what is e to what power equals 5. Well, this equation's in exponential form. If we want to solve this, we want to turn it into log form. What does this look like in logarithmic form? Okay, so logarithmic form, again, the base of the exponent, which here is e, is going to become the base of our log. So that's logarithmic form, and the base here, that's e, should be the base of our log. So we got log base e of 5 equal to x. Well, remember we said log base e is the same as the natural log of 5. So now if we wanted to figure out what that value is on our calculator, we can type in ln 5 and figure out about what that's equal to. ln 5 is about 1.61. So here, that exponent would be about 1.61. On B, we kind of want to do the opposite here. ln of what equals 0.6931. We want to change to exponential form because we can't do log of x. So if we rewrite this one in exponential form, we can solve it. Okay. Remember, ln of x is the same as log base e of x equaling 0.6931. So if we change that back to exponential form, we'd have x equals e to the 0.6931. Now it's a calculator problem. We go on our calculator and we type in e to the 0.6931 power. We get pretty close to, it looks like it's pretty close to 2. Pretty dang close to 2. So sometimes switching back and forth between log form and exponential form is very beneficial to solve the problem. All right, so in order to solve problems, we always want to use inverse operations. We've done before, way back in pre-algebra, you looked at how you can solve inverse of multiplication to solve. We divide. So if we wanted to solve this, divide by 2, we can figure out the answers too. You've done that kind of inverse before. We've looked at a lot the last couple of years about exponents. If you want to do the inverse of something to the second power, you take the square root, and you can do different types of roots to find the answer. Here it'd be plus or minus 3. Well, with logs, if you have log, the opposite or inverse operation of log form is exponential form, and exponential form, it's log form. So you always want to do the inverse. Since e to the x and ln x are inverses, we use the opposite to solve. And that's what we're going to do here for problem 6. We're going to use the inverse to do it. So to solve number 6, we want to solve this and try to get this exponential part by itself first. The first thing we need to move is this 7. We're going to add 7 over. So what we end up with is 5 e to the negative x equals 9. Now we want to keep solving that next thing, divide by 5. Get the exponential part by itself, and then we can hopefully get our solution. We'll continue this and learn how we can use logs to finish solving that tomorrow.